This is lesson 11.1, areas of parallelograms and triangles. Your objectives are to find the perimeters and areas of parallelograms and triangles. Find the perimeter and area of each parallelogram or triangle, round to the nearest tenth if necessary. The perimeter is the distance around, and in a parallelogram, opposite sides are congruent, so that side is 11, and this side is 5. Add the way around. 5 plus 11 plus 5 plus 11, and you get 32 meters. For the area of the parallelogram, area equals base times height. I know the base, which is 11. I don't know the height. But they give us a 60-degree angle and a right angle, so I know that I have over here a 30, 60, 90 triangle. We know the hypotenuse is 5. Since the short leg is half the hypotenuse, then this little part's 2.5, and the long leg is short times the square root of 3, so the height would be 2.5 times the square root of 3. So 2.5 times the square root of 3 for my height, and when I punch that in, that's 47.6 meters squared. Again, remember, to get the height, we had to take half of the hypotenuse to get 2.5 for the short leg, and the long leg is short times the square root of 3. Find the perimeter of the triangle. Well, I know one side. I'm missing that side and that side. To find those two missing sides, if I look here, I have a right triangle. I know two sides of the right triangle. I can do the Pythagorean theorem to find that one side. So 15 squared plus 17 squared equals x squared. That's 514. Square root both sides, and x is the square root of 514. Now for the other side is the hypotenuse of the big triangle. And again, I know two sides of it. I can do the Pythagorean theorem to find this side. One side's 17, the other leg is 40, because you put the 15 and the 25 together, and that equals the hypotenuse squared. That's at 1889. Square root each side, and x is the square root of 1889. Add those three sides up now, and I'll have my perimeter. $25 plus the square root of 514 plus the square root of 1889, and that is about 91.1 centimeters. So we had to do the Pythagorean theorem there to find some missing values. Add the sides up, that's your perimeter. Find the area of this triangle. Well, for a triangle, area is 1/2 base times height. On this triangle, the base will be 25, and the height is the distance from the base to the top, and that'll be the 17. So we've substituted in our base and height, work that out, and we get 212.5 centimeters squared. Always substitute in the correct numbers. We didn't include the 15 in the base because it was not part of the base. Only do the length of the base, which in this one is 25. Question 9. The base of a triangle is 4 times its height. If the area of a triangle is 242 square millimeters, find its base and height. So we have a triangle where the base is 4 times the height. Let's use the area of a triangle formula. Area is 1/2 base times height. We're going to solve for the base and the height. I know the area, which is 242. The base is 4 times the height, so for B I will substitute in 4h. And for the height, since I'm doing the base in terms of the height, I will keep the height as h as well. So let's solve this. (242) equals 1/2 of 4 is 2, and h times h is h squared. Divide both sides by 2. And h is 121, or h squared is 121. Square root each side, and h is 11. So the height is 11 millimeters. The base is 4 times that, because the base is 4 times the height, so 4 times 11 is 44 millimeters. So watch for those situations where they give you the area and they ask you to find one of the other variables. Substitute in the area for A and find the variable you're missing. This is lesson 11.2, areas of trapezoids, rhombi, and kites. Your objectives are to find the areas of trapezoids, rhombi, and kites. Number 1, we have a trapezoid. So we will use the formula for the area of a trapezoid, which is 1/2 height times the sum of the bases. Substitute in the values and solve. The height is 5, and the bases are 31 and 16. That gives you a grand total of 117.5 meters squared. On that one, we knew all of the values we needed, so we just substituted right in. On number 3, we have a kite. The formula for area is 1/2 diagonal 1 times diagonal 2. Well, I know diagonal 1 is 16.4 inches, but I don't know the other diagonal. Since a kite is symmetrical, The top half is 2.4 and the bottom half is also 2.4, giving a grand total of 4.8. So now I have my two diagonals. Half of 16.4 times 4.8, and that's about 39.4 inches squared. Make sure you substitute the correct piece. Since half of the one diagonal was 2.4, we had to double it to use 4.8 in the formula. For number 6, we have a rhombus. Area is half diagonal 1 times diagonal 2. Well, we only know part of the diagonals. Remember, in a rhombus, the diagonals are cut in half. So if this part's 5, the other part's also 5. And if this one's 2, the other one is also 2. So the numbers we put in for the diagonals will be the whole pieces, the 2 5s making a 10, and the 2 2s making a 4. Work that out, and you get 20 centimeters squared. Remember to substitute the correct numbers in. We had to take the half diagonals and make them into whole diagonals. Find each missing length. Number 7. A trapezoid has base lengths of 19.5 and 24.5 centimeters with an area of 154 centimeters squared. What is the height of the trapezoid? Well, we need to use the values we are given, the area of a trapezoid formula, and solve for what we don't know. I know the two bases and the area, and we're going to solve for the height. Area is 154. I don't know the height, so we'll leave it h. And the two bases are 19.5 and 24.5. Simplify the right doing the parentheses there. And we get 44. On the right, multiply half by 44. And you get 22h on the right side. Divide both sides by 22, and h is 7. So the height is 7 centimeters. Remember to substitute in the values that you know, solve for what you don't. This is lesson 11.3, Areas of Circles and Sectors. Your objectives are to find the areas of circles and the areas of a sector of a circle. Find the area of each circle, round to the nearest tenth. For this circle, to find the area equals pi r squared. And on this circle, we don't know the radius, we know the diameter. If the diameter is 24 inches, the radius is half that, which would be 12 inches. So in the formula, I will substitute in a 12 for the radius. Solving for the radius, make sure you punch in the pi button and not 3.14. And you get 452.4, and the label is inches squared. So if you know the diameter, take half of that for the radius and use the pi button. Find the indicated measure, round to the nearest tenth. Number 4, the area of a circle is 3.14 square centimeters. Find the diameter. Well, if the area is 3.14, I can substitute that into the area of a circle formula to find the radius, and then just double the radius to find the diameter. So let's substitute. A would be 3.14. I don't know the radius, so I'll solve for the radius. Divide both sides by pi. Pi cancels on the right. 3.14 divided by pi is close enough to 1. We'll just call it 1. And then r squared is on the right. Square root each side, and the radius is 1. Remember, we're looking for the diameter. The diameter is 2 times the radius, and 2 times 1 is 2. So the diameter is 2 centimeters. So use the area formula, substitute in the area, solve for the radius, and double the radius to get your diameter. Find the area of each shaded sector, round to the nearest tenth. Number 8. For this sector, let's use the area of a sector formula. The area equals the central angle measure over 360 times pi r squared. Remember, pi r squared is the area of the whole circle. We don't want the whole circle, we just want a fraction of it. What fraction would that be? It's the central angle over 360. So let's substitute our values in. The central angle measure is 37 degrees. The radius is 19 meters. So I can punch all that in, and the area of the sector is approximately 116.6 meters squared. Area of a sector is the central angle over 360 times pi r squared. This is lesson 11.4, areas of regular polygons and composite figures. Your objectives are to find the areas of regular polygons and find areas of composite figures. Find the area of each regular polygon, round to the nearest tenth. For a regular polygon, the area is equal to half the perimeter times the apothem. For a triangle, we know one side is 14, so the perimeter is going to be 14 times 3, which is 42. And then for the apothem, I can use my apothem chart using apothem equals side over 2 times the tangent of 30 degrees. I got that from my apothem chart. A side length is 14. So 14 over 2 times the tangent of 30. Which is about 4.04. So for the apothem, I'll put 4.04. When I substitute that all in, I get 84.9, and that's centimeters squared. So remember, when you need the apothem, use your apothem chart, substituting in a side length and using the appropriate angle for tangent. Number 2 is a regular pentagon. Area equals half perimeter times apothem. I don't know the perimeter, but I can find a side length. If I use my apothem chart to get the measure of a side, A side equals 2 times the apothem over the tangent of 54 degrees. 54 degrees is because it's a pentagon. So 2 times the apothem here is 7, divided by the tangent of 54 degrees is about 10.17. So if one side is 10.17, multiply by 5 to get about 50.85 for the perimeter. So I'll substitute that in, 50.85, and the apothem is 7, making for a grand total of about 178.0 meters squared. So when you know the apothem, use your apothem chart to find one of the side lengths, 2a over tangent 54 degrees. Since there's 5 sides, multiply the side length by 5 to get the perimeter, and use the apothem. Find the area of each figure. Round to the nearest tenth if necessary. For this composite figure, we need to look at it and determine what type of shapes it's divided into. Since I have a curve over here, I can see that it should be divided right about there into a semicircle. And there's also a congruent semicircle cut out of this side. So what I can do, imagine taking this semicircle, cutting it out, and replacing it over here. So essentially, what I have then, instead of this type of figure, really, I have, when that semicircle is put in there, I have a square that's 20 by 20. For a square, the formula is s squared. A side length here is 20, and 20 squared is 400, and that will be millimeters squared. So since I was able to take the one piece and slide it into the other slot, really what I have is a square. For number 6, I have a composite figure that I'll just divide into different shapes and add up the areas of each one. Well, I see the curve over here, which means I'm going to have a semicircle, which I can divide. And I also have a piece over on the left and a piece in the middle that I can see will be divided right there. So really what I have is a square, plus in the middle I have a trapezoid, and on the right I have a semicircle. So I can add up the areas of each one. The formula for the area of a square is s squared. The formula for a trapezoid is half height times the sum of the bases. And the formula for a semicircle is half pi r squared. Let's substitute the values in now. A side of the square is 13, so 13 squared. For the trapezoid, the height of the trapezoid is right there, that's 20. The bases of the trapezoid, that one's 13, and that one's 30. And the radius of the semicircle, it has a diameter of 30, so the radius will be 15. I'll punch all that in. (952.4), and that will be inches squared. So determine what shapes you have, use the area formula for each shape, substitute the values in, and add them all together.